Welcome, everybody. Thank you so much for taking time out from the eclipse today to join us for this data session. And normally Susan Vincent would be doing the next in a little introduction here, but I'm going to let Nate Vogel jump in and give an introduction for himself, and he's going to share some information about GPS and mapping, I believe, today. So thank you for joining us, and it's all yours, Nate.
Hey, hi everybody. So I'm Nate Vogel. Nice to see everybody. I'm director of the Digital Innovation Lab at Community Legal Services in Philadelphia. We are slightly off of the path of totality, so we're gonna have like an 80% solar eclipse today, something like that. I hope everybody's gonna get a chance to enjoy that. So at CLS, my job is I work on a lot of software development and data analysis projects. And a big part of my job is to try to integrate tools from the worlds of open source software, data science, into the work that we do at CLS and support our advocacy, and to support our clients in the communities where our clients live. So we use maps a fair amount in that work. Susan, Vincent, and I talked about wanting to have a conversation like this. I've put together some slides to talk about different ways that sort of different like concepts with mapping and things like that. But I also thought it would be really nice to have to hear from others too, if folks want to talk about sort of what your challenges are, how you use maps and geographic data. What are some of the challenges that you have? So I'm going to share my screen, and we can look at some visuals and things that I have. But I'm also really interested in hearing from everybody on the call, and we can kind of brainstorm about what our goals are in terms of using geographic data and what we need to learn and what we're trying to figure out and all of that. I'm going to try to pay attention to the chat too, to like see if questions come in. But I may also get distracted. So if somebody wants to like pop in and say like that I'm missing something, please go ahead and do. I'm going to share my screen. All right. Well, so I wanted to start with a question. What are maps actually for? What are we trying to get out of? We've heard for years, oh, like maps are really cool. We should like do stuff with maps. But concretely, I'm really interested to hear what folks do with maps already, or what you hope to use maps for. Like, what's the point of maps for you or for your organization? I can throw out a couple ideas. Something that we use maps at CLS for is for helping give context to the work that we do. From one perspective, we sit in an office, people come to the office, we do some legal work for them, and then they leave. And it's hard to understand, sort of to like place that day-to-day work in the broader context of the need for legal services in our jurisdiction, in our geographic area, which happens to be Philadelphia. And for us, maps are a really great way to sort of contextualize the need that exists in our geographic area. So you can see on the page here, you can see a map of this is the levels of poverty in different zip codes across the city of Philadelphia. And so darker shaded zip codes are areas where there are higher levels of poverty. Lighter shaded zip codes are areas where there are lower levels of poverty in the city of Philadelphia. So we can get more context about sort of where do the people live who might need the services that we're providing, and we can use that to try to decide where to hold outreaches and clinics and things like that. So that's one thing that maps are good for. Are there any other? Okay. So there's some chats, mapping case data, numbers of requests by county. I'm curious. Like can we take that another step farther? So why would you want to know the number of requests by county? What would you do with that information? Yeah, yeah, showing legislators how many of their constituents are being helped with their funding. That's yeah, I think that's another really good one. Using maps to support advocacy, using maps to explain to stakeholders who may not care specifically about housing, or they may not care specifically about utilities, or but they do care about the people who live in their particular geographic area, and you can show that with geographic data, you can show like there's this many people who you care about live are getting the kind of services that we're able to provide. That's great. We look at requests by county to see if our outreach is effective, and also just trying to compare with census poverty data. Yep, that's great. Yeah, that's great. Um, so I'm really curious too. So and I want to know also that'll help I think guide this conversation, where folks are at in terms of what you're doing with maps already, what you're trying to do. What is the next thing that you want to learn to do with maps and geographic data? And I'll throw out one thing, for me, something that I'm really interested in is trying to integrate like satellite data. So I did a little project a while ago looking at temperature data from satellites, and comparing satellite data to comparing the temperature data to poverty levels in Census Tracts in Philadelphia, and using that to identify like high poverty uh, and also very hot parts of the city, to try to integrate, recognizing that especially as climate change accelerates, uh, climate will drive a lot of needs for legal services, like needs for utility support, for example. And I think there's probably also a lot to do with like flooding and things like that we're going to want to pay attention to, especially in helping clients get connected to services to support like repairs and things like that. Um, yeah, we're using maps. Yeah, looking at comparing need and demographic data. Yeah, that's great. That's great. Yeah, integrating multiple different sources like census data from one place and legal server data from another place is definitely really valuable. And that's this yeah, and we can talk about some examples of how to do that in like specifically. So there's a lot of different tools for making for making maps. So I want to talk about like I tend to use one set of tools. Other people may use other sets of tools. In this conversation today, I thought it might be neat to might be helpful to talk about sort of what are the general concepts that we use when we're dealing with the geographic data and mapping data that apply no matter what tool it is that you're using. So here's some examples that I know about. If other folks have examples that you like, feel free to like shout it out, stick it in the chat. Looker is actually the one, this presentation that you're seeing right here is made in Looker. Looker is Google's product. I guess originally maybe it wasn't, but now it's Google's product, and it's a sort of BI business intelligence tool, and it can do maps pretty well. And we'll see some maps that Looker can do in just a slide or two. Power BI is one. If that may be one that is maybe pretty common in legal services. Power BI I tend not to use as much for various reasons. And if we want to talk about the pros and cons of different platforms, that's always fun too. Click is another really interesting one that I've used a lot. It's another cloud-based service. If you're really only doing geographic data, I think ArcGIS is probably the sort of the elephant in the room there for geographic data. There are some other maybe tools that folks in legal services don't know as much about, that are also really cool. So this big Q right here, this is QGIS, and I'll spell this in the chat here, QGIS. And QGIS it's an open source free desktop application that I think is meant to kind of be an open source clone of ArcGIS. and you can do great maps with QGIS. It's a little more DIY than something like Power BI and Looker, but you can make great maps, and you can also there are really great layout and presentation tools in QGIS too. So I really like QGIS. But you also, if there are coders on the call, these tools, Looker, Power BI, Click, ArcGIS, QGIS, these are all tools that give you a nice user interface with like buttons, and you drag and drop stuff, and give sort of a nice like drag and droppy, clicky interface. But you can also do, there are a lot of really great tools out there for using code to design maps and do various kinds of spatial analysis. If you're a Python user, you may be familiar then with pandas, which is the sort of big like tabular data library in the Python data science world. And GeoPandas is the spatial library that helps you do spatial analysis within pandas data frames. So GeoPandas then is like the library is like the go-to library for geospatial analysis in Python. Um, if you're an R user, there's a whole set of other R tools as well that are great too. So doing this kind of thing in code is also wonderful. Yeah, and if anybody has any other like tools that they love, feel free to shout it out. All right, so I thought another thing that I'm really curious to hear about from folks is about what common challenges are that you might have. So I'll throw out one thing that I know is a challenge that I tend to struggle that I often come across in using geographic data, which is normalizing data. So maybe like raise your hand or something if you've pulled out census tract data from legal server. Is that something that you've done? Um, um, so if you're pulling out census tract data from legal server, you might notice that it comes out in a particular, yeah, there you go, yeah, so it comes out in a particular format. There's like 42 census tract and then some numbers. And then if you're pulling census tract data from somewhere else, like the American Community Survey, the format will be slightly different. So for me, I think normalizing data has been something that I routinely have to do with geographic data. Do folks know what normalizing data, what that term is? That just means taking data in one format and data in another format, and then sort of massaging the format so that everything kind of like matches up, so that a census tract that's labeled as 42 Pennsylvania 1 2 3 4 5 gets mapped to, and then another one that's just labeled as 42 1 2 3 4 5. It's you can normalize those so that they have the same string representation. Any other like common challenges that folks have that you want to talk about on this call with geographic data that you come across? Cool. Okay, great. Well, everybody's yep.
I don't speak your language. I think that's my biggest challenge. You were just talking. I'll admit it. I kind of just feel like I'm figured something out and then I run with it. And then I know there's probably a better way to map it. Like I'm just watching you give examples or seeing other people's examples, like, oh, that platform does this. But I really don't know what's out there or what's a simpler way to do it until I see it. So I guess that's my biggest challenge is like I've I have access now to ArcGIS online, and that's all I know how to how to use. So the shape files, I don't understand how to pull those in. Like I've seen that in Power BI, pulling in even the icons of shape files, but I don't know I don't know how to put the shape of Michigan in there and get it to work. So I guess my second challenge is just understanding ArcGIS credits. Like I'm afraid to do things because I'm afraid I'm going to use up all my credits and I can't find anything or figure out how much what something costs because we only have 1,000 credits, so I just don't do as much.
Interesting. Okay, cool. Awesome. Okay, so let's talk about where to get geographic data. So yeah, okay, so shapefile. So when we're creating maps, we need geometries to put on a map. The geometries are probably going to represent, Michigan or Pennsylvania or the census tracts of Washington State or some sort of like place that you want to care about. First, I'll say that if you're using depending on the tool that you're using, you might not need those shape files at all. So let's look at let's like zip forward a little bit and look at in Looker. So in Looker, you can build a map, and you know what we're gonna do? Let's actually get rid of this map, and we're gonna recreate it. All right. So here we have. So I've got some synthetic data. So I actually had Claude, which is Anthropic's Chat GPT version, invent some data for me. So we've got name data, we've got a column of names, we've got a column of ages, we've got a column of zip codes, and then we've got a column of latitude and longitude. And what I'd like to do, so let's say that this is a table of our clients who we helped with evictions. So these are our clients we helped with evictions. We want to see, we want to put these cases, we want to put these cases on a map. So with Looker, and I think with other tools, with others like the cloud-based tools as well. I think Power BI does this as well. Probably you don't actually need the shape files at all. These cloud-based tools come up with the images of the maps for you, so you don't need that part. So what you can do is with a tool like this is I'm just going to add a chart. And in this case, I want a filled map because I want shapes with color. I want shapes colored in by how common something is. And so what I'm going to do with that then is, so I've dragged this map. I've got a data source, which is the example tabular data that I've got, which might be from Legal Server. And the location here, what I've done is I've told Looker that the zip code here, that the zip, let's edit the data source. That's what I'm gonna do. So I've told Looker that the zip code field is a geographic field. The type of the field is a geographic field. And specifically Looker, this is one of the reasons that I really like using Looker, is that it does this part, for me really nicely. This column is zip codes, and I've set this column to be geographic zip codes. Now Looker knows that these are supposed to be this is supposed to be geographic data. And so now the zip code is geographic data. I can zoom in a little bit and I can set the color metric. So the color of each geographic area is now going to be set by the record count. So the number of rows in my underlying data table that have zip code 19102 or that have zip code 19134, zip code 1, etc. Here's a map where those numbers are not all different. So like this is another like fake data set. So you see how, again, so this is using another geographic data with different the like geographic column. is the name of a country, and Looker is smart enough to know that the name of the country corresponds to each of these geometries, and then it's colored in by this column important quantity, which is just a made up number that only exists to give different colors on this map. So some tools you don't need the shapefiles at all. For other tools, ArcGIS, I'm afraid I don't know specifically how to load shapefiles into ArcGIS. But if you're looking for finding shapefiles, there are lots and lots of public resources online for getting shapefiles. And so let me show you just one that I go to a lot for in Philadelphia. So open data Philly, and so this is not going to be your data set, but this like process of finding shapefiles is probably going to be similar. Open data Philly data sets, council districts. All right, so here we have we have data sets of geometric shapes for a bunch of different in a bunch of different formats. So the shapefile is one format. GeoJSON is another format. I actually really like GeoJSON as a format as opposed to shapefiles because it's a little more. You can actually look at it here. Here's this table. This is an example of what a GeoJSON file looks like. It's just a text file, and so you can't actually look at it and see that it's got the shapes that it has, what the features are, what the geometries are in this shape file. And then once you've got that shape file, how you load it into a particular tool is, I'm afraid, that is going to vary by what software you use. And I just don't use I don't use GIS, I'm afraid. Okay, let me see if I can pull open the comments again. Are there, I can't see the comments. Are there comments?
So the last comment that was typed was, I find getting exactly what I want out of the census data challenging. And then there was another one,
Oh, yes.
ArcGIS seems neat, but budget, I have heard, is an issue due to space requirements with tokens. I had a student license in uni, so can't speak to this too much myself, but this is something I heard from a previous conversation, so just wanted to see if that was a common pain point. But sounds like it is from Susan's comment. So getting back to that census data, do you have any comments on that?
Yeah, census data is really tough. So I actually tried something recently that worked fairly well. I actually asked ChatGPT to tell me a census table that I wanted to know about. And it turned out to be wrong, but it got us really close to the right table to use. So actually going forward, I think that's probably where I'm going to start, is asking Claude or ChatGPT for the census table that has the right information, and then use that as the starting point to find like quite the right table that I'm going to want to find. And for ArcGIS, let me just like plug again QGIS. I think if you're used to using ArcGIS, QGIS might feel very comfortable. And it's going to be totally free, and it's going to run on your computer, and it's going to have all the sort of interfaces that it's trying to be a lot like ArcGIS. So I think QGIS might be a really useful thing to try out. And there's not going to be any credits or anything like that. You're just going to use it. So I hope that helps. I hope QGIS might end up being helpful for folks. Do folks use are folks used to collecting geographic data out of Legal Server? Yeah, maybe not.
While we're waiting for those answers, we did get another comment if you'd like. So,
mm-hmm.
Okay, so the comment is something I'm wanting to do is building a map in Power BI that will let me toggle on or off different kinds of maps based on both our case data and also public data on things like demographics, income levels, etc. I've been able to build a map based on a single source of data through an API, but haven't figured out or found a good training resource on how to import public data. Let's say income, for example, normalize it / map it where appropriate to my case data, and then be able to set it up so I can toggle on or off the map overlay. Any recommendations on training support in this area?
Yeah. So with Power BI, you can use Power. Are you familiar with using Power Query? Um, you can use Power Query to collect out external data sources into Power BI. Um, uh, I personally do not prefer to use Power BI and Power Query for that kind of thing. I prefer. I think it's a lot more straightforward to collect the data either through a script, collect external data either through a script or even manually downloading it, clean it up myself, even in Excel, and then once I've got that like cleaned public data, um, then use the data that I've cleaned outside of Power BI in inside Power BI. You can also do a lot with inside Power BI. The M language, I think, is actually pretty good. Power BI M language. This takes some learning, but I think it's a pretty good. But it's pretty good. It's a language that you can use inside Power BI to do kind of arbitrary data transformations that you want to do. And so you could make an HTTP request to the American Community Survey. Again, Claude will write an API query for you. So actually, we can probably do a little demo of this. What census table will tell me the poverty rate by tract in Philadelphia? Let's see, live demos are so dangerous. So if we're really doing this, we go to the census site and make sure that this is actually true. This may not be right, but assuming that it's true, can you write an API query for this table? There we go. And I bet this will give us something. Okay, well, nope, not quite right. In no, all right, well, okay, that's not quite right, but it's pretty close. You can use this as a starting point to get to the HTTP request that you want to make, and then what I might do is then in Power BI using their data connectors, put this API request into Power BI, and that's how I would get the data into Power BI. Use M to clean up the data that comes back, and there is an interface in Power BI for sort of moving around, uh, cleaning up tabular data more manually than with the M script. Although interestingly, what that's doing is it's going to be recording the M query like steps that you're doing, sort of behind the scenes. So you can then like go into the M editor and adjust it to make sure it's actually doing what you want it to do. And then in terms of toggling layers, I'm not sure, but I wonder, let's look at how this might work in, so I think these tools all kind of have similar similar structures. Looker, Power BI, Click, they all do kinds of similar things. So what I might try is looking for something like a blending data. Like, okay, so there's this join data operation. I would probably start by just making multiple maps if I want to like visualize different things. If I really do want to blend tables together, actually I kind of did this in this map here. Where is it? In Click, what I did with this example, and you might try this in Power BI as well, is I set the geometries, the color, the fill of the geometry was the poverty level of the city, or sorry, no, it was the temperature. The fill of the geometry was the temperature, and then the outline of the geometry was the poverty percentage for the census tract. And so in that way, you can see you can sort of compare in one visual like two different measurements. So that's one way to do it, like using those two different channels, like fill and outline color, to like merge two different layers. Otherwise, having like side by side maps is also, I think, it's also, I think, good. It's very, I don't know. I'd be really interested to see what you end up doing, if this group wants to like share around demos. I have not personally had a lot of success with having like multiple different like measurements on the same map. As you can see in this example, like I think it is kind of noisy and it's kind of hard to tell like what it means from looking at this. Side by side maps can be a little bit easier. Or you could create a combined measurement, that you can get one measurement that like merges both like poverty and temperature. So maybe you like multiply those two things together to create one measurement that you map, instead of trying to map two different things to compare them across to compare them across the maps. All right. So some other things that I thought might be helpful might be helpful, sort of like general things to talk about. There are lots of lots of places besides the U.S. Census to access data. There are geocoding services out there that are free or low cost. If you want to turn like addresses into latitude and longitude coordinates. These are a couple that I've used that I think are really good. Google has a geocoding service, but their terms of service for that geocoding service are actually very restrictive. And I don't know that you'd get punished if you use it outside of the terms of service of that website. But those terms, you do want to pay attention to what those terms are. There are other services. OpenCage is a commercial one, but it's very low cost, and we've used it. We've used it a lot to geocode locations. This is and then this one at Texas A&M GeoServices is also another really good one, and I think they have a really good free like a free tier as well. So there are great geocoding services out there. Yeah, like general things that we might do with maps and different services. As long as you're able to get latitude and longitude coordinates, you can put dots on a map, which Looker can do with, and Power BI and ArcGIS can all do pretty easily. Shapes on a map, we use you can find geometric shapes like shape files or GeoJSON files, and then some platforms like Looker do that kind of thing automatically. Coloring shapes we've talked about. I'm also another thing that I'm really interested in, and I'm curious how folks do this. We've talked about Power Query, but there are lots and lots of different ways to ingest data. So you've got I've got data on legal server, I've got geographic data on legal server, and I've got census data, and I've got open city Philadelphia data reporting um, licensing and inspection violations. So you may have similar issues where you've got heterogeneous data sources, data coming from lots of different places. What do you use to collect that data, transform it into like common structures that you're able to merge together, and then load it into your mapping tool of choice? There's a lot of different options here as well. I'm curious what folks use for that kind of thing. I've been using I've been using Dagster a lot lately. Excel and Power Query. Yeah, yeah, cool, very cool. I bet, yeah. I mean, Power Query. I'm sure people would love to hear about like expert Power Query use. I'm not an expert with Power Query. I'm not sure I've ever used it at all, beyond a little bit of using the M language. I use Dagster now for a lot of stuff, which is like based on Python. It's a Python based framework. Apache Airflow is also a Python based framework for ingesting data. Power Automate. I know there's folks on the call who use Power Automate as well. That's another really cool option for um, running jobs that collect some kind of data, do something to it, and then store it somewhere else. Uh, do you like Tracy says Excel and Power Query? Do you like using Power Query? Do you feel like it like does what you wanted it to do, or is it frustrating?
So I figure speaking up might be easier than typing. Um, I like Power Query. It can be frustrating, especially if you have to go in and try and fix broken pieces within the query. Um, but I find the more I use it, the more comfortable I get with it.
That makes sense. That makes sense. That is also why I think like what you're pointing to is also why I tend to like stay like shy away from like Power Query type tools. I think like you're writing one long expression that does everything you want it to do, right? Like it's hard to name things and then combine expressions together.
Yes.
Yeah, yeah. That's why I find it so frustrating. And then in Excel and like Microsoft tends to give you just like these little tiny boxes to do that in.
Yes.
Yeah. Um, M is actually cool. This is another reason like I like M because you can write out like step by step. Download the data, assign that to a variable, add a column to what you just downloaded, assign that to another variable, and then you can like see that step by step by step. But it's still inside of Power BI, which can be nice. It's like sort of bridging the gap. Like you don't have to figure out how to like set up a Python environment or something like that. But you can do it all inside Power BI. But you can like stepwise look at stuff as it proceeds. But yeah, I mean, it seems like Power Query can do like all the things. You can like collect data from legal server. You can collect data from anywhere on the web. You can collect tabular data from wherever you want. I recently learned Power Query can read Parquet files, which is neat because Parquet is just like a nice data storage format that works well with Dagster. So that's why I was interested in it. Yeah, I don't know. There's maybe if folks are interested, I think it's interesting the things that you can do. So we're talking about maps, but we're also talking about geographic data more broadly. If you're using geographic data, there are like mathematical operations that you will commonly want to do. Like is a certain point inside a certain geometry? Like, is my house inside a particular council district? Um, uh, and I think you'll see, especially like ArcGIS and QGIS and any of the programming languages that you do geospatial stuff, um, provide helpful interfaces for doing these kinds of common geographic, like mathematical operations to try to figure out, are geometries intersecting, or can you find all the census tracts that are some part of the health improvement zone in this area or something like that. Yeah, so I put this slide here in the hopes that there's some expert on this slide, on this discussion, who would be willing to teach us all about geographic projections and what it is what we need to know about them, because I know they exist, and but I don't know much more about it than that. So if there's anybody who knows a lot about projections and can teach us all about them, then that would be swell. Or if you can just tell us that we don't need to know about it, then that's great too. Well, so maybe let's just open the floor. Like, do people want to talk about projects that other projects you're working on? I think it sounds like there's probably a need for like tool specific conversations, like how do I blank in software blank? That would also be useful. What are some of those sort of more like focused conversations that would be useful to have?
So we did get a question in the comics. How are the tools at documenting your data sources? I tend to work in CSV/XLS files because I'm comfortable with ways I can carefully preserve information about the source data, where and when the data is based on. So the question goes back to, how are the tools at documenting your data sources?
Yeah, so I think so yeah, if what you want to document, so if you're pulling data from like an online source and you want to document when the data is from, I think one way that I've done that is to have the code add a column that records just the current date. And then so you've got a column in a table that has the current date. So that's one way to sort of automate recording that data. If you're using QGIS, ArcGIS, Looker, they don't automatically store like when the data was collected. They store where the data is from if you're pulling from an online source, because the URL of the online source is in the code of the project. But when you pulled that data is not going to be preserved. I think what I am working on currently is so what I use Dagster for is running jobs that collect some data, store it in a storage somewhere, like a data lake, sort of like a mini data lake, and what I'm working on now is extending that to, and this is like a very common thing that that like out there in the industry world, folks have been doing for a long time, storing data in like with like in like they call it partitions in Dagster. So you store data with metadata about when different instances of the data that you've pulled were collected, and then in your metadata you and then using that metadata you can rerun your visualizations and surface the metadata that you've previously stored, and then you could like run the map as of today, but then rerun it as of whatever you had in January, and you could like compare things like that. But yeah, QGIS, Power BI, Looker do not by themselves store the time part of that. They store the where it came from, but not the time part. So that is interesting. That would still be up to you doing something manually. I mean, if you're putting something in a dashboard, you can just add like some text, which I imagine is like kind of what you have to do with Excel anyway, like data as of for 2024, and then every time you come to this dashboard and you re-upload or you like refresh it, then you could renew this timestamp, but that is pretty manual. That's not ideal. I think the state of the art would be like partitioning and sort of collecting. They call them like slow moving dimensions, to have like a slow moving dimension of data that you like collect over time and then store metadata about different instantiations of the data. Anyway, that definitely gets complicated.
I thank you for doing this. I would love to have more detailed conversations in the future. I think I have things to share, the things that I've done, and I'd love to look at your recommendations to see if I can replicate in the free software. I have to leave. I gotta go check out this eclipse, but please put me on the list for future discussions on this. And thank you so much for your help.
Thank you. Yeah.
So Nate, is this about the time where Susan has normally turned off the recording? Are you familiar?
Possibly, I don't remember, but maybe. Yeah, that sounds reasonable.
Okay, let's do that, and then